Hello ladies and gentlemen, and welcome to another screencast by yours truly, Mr. Stano. Today we're going to move on to thunderstorms. Thunderstorms are going to be associated with low pressure. Remember low pressure, rainy conditions from that rising air. But these low pressure systems are going to have extremely rapidly rising air that are going to produce heavy rains, thunder, and lightning. Most common type of storm that we see in the United States, approximately 2,000 occurring at any given point in time, and they're going to be associated with warm weather. Remember, warm air is less dense, rises, the warmer the air, the faster it can rise. Fortunately, though, these thunderstorms only going to last for a very short period of time. Most frequently, we see our thunderstorms really hitting in the southern parts of the United States where it's warmer, and during the summer you can see them in New England area too, in the Northeast. But typically throughout the course of the year we're going to see a higher number down in the southeastern part of the United States where it's a constant supply of warm, moist air. This is what a typical storm cloud may look like. This just happens to be a really bad one right here. You can see how dark it is underneath. So there's a huge amount of water droplets in the air. And if we notice that this cloud weighs, they're estimating at around 226,000 pounds. It's the collection of all those water droplets in this cloud. Pretty heavy. This is looking down on a thunderstorm. What's pretty cool about this picture is you could see this right here. That warm air rising up and then moving out in each direction. When we think of thunderstorms, we think of lightning. This lightning is due to electrical charges. The top of the cloud is going to be positively charged. The bottom of the cloud is negatively charged. This is due to all the movement of water droplets in that cloud from this rising and moving air. So we end up getting is these transfer of electrons. It's positive on top, negative on the bottom. Eventually, the positive charge from the Earth reacts with the negative charges in the cloud, and we get our lightning bolt. So these clouds, like I said before, they get charged because of these collision of the large and small particles in a cloud. That's all those water droplets. And as these air moves and these particles are hitting each other, electrons are transferred, and we get a buildup of electrons from one top to bottom of the cloud. Large particles are negative and small particles are positive. Remember, the small particles can stay higher or more suspended up into the cloud. And these are some lightning facts for you. We have about 40 million times each year there are lightning strikes. Lightning bolt lasts for only 1/10 of a second, but has enough power to be about 30 million volts. And an average thunderstorm is more powerful than an atomic bomb. So huge amount of energy stored in these low pressure systems associated with that warm, moist air that's rising. Here's some more lightning facts for you. The lightning bolt, the air around it can heat up to about 50,000 degrees, which is important to remember. That's a huge amount of energy, a huge amount of heat energy, and what happens is it causes the air around it to expand. Remember, as things heat, they expand, but it does so violently that is what creates the thunder. And that is why we see lightning first. Well, one of the reasons why we see the lightning first and then the thunder later on. It's the lightning that causes the thunder. Here's some pretty cool pictures of lightning. Here's some more. And a time-lapse photography of a thunderstorm with all the different lightning strikes. It's pretty cool. Okay, this is prior to a launch of one of the previous space shuttles. House hit by lightning. Not too fun. And then we have this guy right here. This park ranger who was hit by lightning 7 times. And you can read the article there. It's pretty interesting. And this is this photograph was taken right prior to one of these boys was hit with lightning, and you can see how the hair started. And you can see how their hair started to rise up due to that electrical charge buildup. Okay, People usually die from lightning strikes because their heart stops. Remember, your heart works off electrical currents, so this huge amount of electricity flowing through, basically stopping the heart right there, along with other damage associated with that lightning. Okay, some things to do. The best position to take is you want to get to the lowest ground as possible and have the smallest footprint. So here, notice he's on the ball of his foot right there. It's a very small footprint, and crouched over, so he's pretty low. Okay, some other safety precautions. You want to seek shelter inside a home or a car. Do not use telephones or take a bath. It's actually been, some people have been electrocuted because the lightning will strike their house and go through the low voltage telephone lines and into them. Same thing, taking a bath. You don't want to be in water. If outside, you want to stay away from anything metal or tall, trees, flagpoles, stay away from that. Don't huddle in groups. Remember, you want to have the smallest footprint as possible and get to the lowest ground as possible. So those are precautions to take during a thunderstorm. I think golfing is out of the question too. And that's it. The next time we meet, we're going to talk about hurricanes. We'll probably break that up into a few little screencasts. So I hope you look forward to them. Have a good one. Goodbye.